What's poppin', dogs? Mr. Allen here. We're about to graph ourselves a wonderfully beautiful cosine function, our most basic of the cosine functions with no transformations, and we're going to use our unit circle values to help us out. So let's go ahead and put our quadrantals over here on the right-hand side. So at 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back around to 360 degrees. All right? So at 0, what does our cosine function equal? That would be at 1. At 90, it's going to equal 0. At 180, it'll equal -1. At 270, it equals 0, right? These are all my x coordinates at these spots. And then back around to 360, it's going to equal 1. So basically, I have these ordered pairs of 0, 1. So 0, 1 would be right up here. Let's go ahead and label our axes, right? 1 and 2, -1, -2. And then we'll say that this is going to be 90 degrees. We'll go with 180 degrees, 270, 360. Here, we'll do that for now, and then we'll go if we need a little bit more. So at 90 degrees, it said it is 0, right? That's my ordered pair right up here. 90 is 0. At 180 degrees, the value was -1, so it's all the way down here. At 270, it was back up to 0. Okay, now this is kind of looking sort of a similar pattern to what we had for our sine function. And then at 360, it's back up at +1. So what we have here is essentially it's going to start repeating itself, because if I were to say go back 90, right? If I go back 90, that's going to be at my 270 ordered pair. That's going to be at 0 for -90. And at -180, I'm going to be down at -1, right? It's going to be my next one as I rotate backwards. And then if I go to -270, a little bit further, I'm going to be back up to 0. And I could actually continue that pattern on over here too at 450, right? So on and so forth. So I've got this little thing going on again, just like I had with sine. I'm going to focus on the first part that we did from 0 to 360 degrees. So this is going to drop down here and then curve on through like that. Oh, it's beautiful. It's beautiful. And then that's one period of this periodic function, y equals cosine of x. The other part still exists, and this is absolutely a part of the function. It's just the repetitive part here. So I'm dashing this so that we can focus on the one period, because a lot of times you'll be asked to graph one period of the periodic function, right? This should really have a little more dashy. There we go. Whoa, got out of control there. Woo, all right. So there we have it. There's our cosine graph. If we were asked for one period, it's just the solid part. If you were asked to just fill up the entire graph, you'd have all that as, filled. So let's talk about our domain and range for our cosine as well. Well, for our domain, it continues going left and right forever and ever and ever. So it's -infinity to +infinity, always with parentheses for those, because you can't include infinity. It just keeps on going. All right. Now my range of this whole cosine function, well, how high up does it go? It goes up to 1. How low does it go? It goes down to -1. Just like our sine function, just at a different spot. All right, so, but still, my range is going to be from -1 to +1. We're including those points because those points are on our graph everywhere, right? So we're including those values. And that's really about it for the introduction of graphing a cosine function. From here, we can shift it, we can stretch it, we can move it up and down. Things get pretty crazy. But they're pretty dope. So you got something to look forward to here, kids. All right, I'll see you later. America Freedom, rock and roll Costco, Riverdog Jenny on the gram, of course, and, Yo-Ro, even though it didn't really apply here, but it's still good to remember. All right, see you later.